After learning, understanding, and appreciating the binomial theorem, which allows us to identify the expanded form of any binomial expression raised to the n exponent, or even the numerical coefficients for very long and very large values, now we will have here the multinomial theorem, which works the same way, but this time we will have a multinomial expression raised to n exponent. So we have this theorem here. For this video, we're going to have its definition and all of its necessary portions of its what do you call this one, its description, and we will have a separate video for illustration and for some examples. So for multinomial theorem, it works like this: for any integer m and n greater than 0. So strictly m and n greater than 0. And if we have here a multinomial expression x sub 1 plus x sub 2, since it's multinomial, we know that it is we could have more than 3 terms. So we have here x sub 3 plus dot 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 until x sub m, where m stands for the number of terms in that expression and n is your exponent. This is just equal to the expanded form, or let me write here at the bottom, equal to the summation of n, the original one, taken over the m-ary sequences, or in the short, n sub 1, n sub 2, n sub 3, dot 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 until n sub m. That's our combination. And we have here x sub 1, the first term, raised to the power of n sub 1, x sub 2 and raised to the power of n sub 2, dot dot dot, or we'll have it until 3 because we ended until 3, x sub 3 raised to the power of n sub 3, dot dot dot, we're multiplying all of them, x sub m raised to the power of n m. Okay, this is its condensed form, and you will have to expand it later on for some illustrations. Okay, where, as mentioned, the sum is taken over all m-ary sequences. Again, we're going to have illustration here: n sub 1, n sub 2, n sub 3, dot dot dot, n sub m, okay, of the non-negative integers with summation of your n sub I, where I starts from 1 to m, is equal to n, and the number of term and the expression, rather, the expression n combination n sub 1, n sub 2, n sub 3 until n sub m, okay, is equal to the combination multiset n factorial over n sub 1 factorial, n sub 2 factorial, n sub 3 factorial until, sorry for this, n sub m factorial. Okay, so this is how the sorry for that, I would like to rewrite this so that I could really enclose it into just one line, equal to n factorial all over n sub 1 factorial, n sub 2 factorial, n sub 3 factorial, sorry for that, dot dot dot, n sub m factorial. This is actually similar to what we learned as combination multiset, and this is the what it means with that here. Because if we would like to go to or return to the binomial theorem, it's actually like this: n taken r, x to the power of n minus r, y to the power of r, as r starts from 0 to n. So this is the combination for the coefficient. So this time, since we'll have more than 2 terms in our, because it's again multinomial, this form here, it follows the combination multiset formula, and all of this will follow the exponent for each of the following number of coefficients for n sub 1, 2, 3, and until m here. So we will have an illustration for this in the next video, and I would like to emphasize it further so that you could actually appreciate this theorem. But before we end, there is a note here. Since for the binomial theorem, the number of terms is n plus 1, Okay, so for, say for example, the exponent is 20, we be expecting 21 terms in the expansion. For the multinomial theorem, again, x sub 1, x sub 2, x sub 3 plus until x sub m raised to the power of n. The number of terms is not just n plus 1, but the number of terms is given by this n plus m minus 1 combination n. This will tell us the number of terms in the expansion if we are asked to, or even if we are asked to really expand. Okay, so it's also one thing to be remembered. So again, this is the complete form for the multinomial theorem. It tells us a lot about the expansion for the any multinomial. Of course, we will have a trinomial and so on and so forth, and we'll have this form. We will have an illustration in the next video. Thank you very much for watching.